When I was making the tool holders for the lathe over there on this Syil mill, I noticed when I'd finished there was a slight ticking noise coming from the spindle, and after investigation it turned out that it was the motor. So I found there was a dodgy bearing in the motor. So join me while we replace that and have a little look in the top of this mill. When I was taking the power drawbar off the mill because of that crash I had, I was just playing and experimenting, and I was running the spindle, and I could hear a tick 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 noise, and it turns out the tick 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 noise is, let me show you, taking a motor off. It's a 1,000-watt motor on this this little Syil mill, and the rear bearing, which is this one, looks tickety-boo, but has actually had it. It's just occasionally you can hear it tick as it goes round. So I have the other thing, years ago when I first had the mill, I found that the spindle was making a funny noise. It was clonking, and what it was the when you buy these this is a T5 belt drive pulley. They come with a pressed on steel side, and whoever made it in China had dented both sides of the steel flange. So the belt, let me put you down. So the belt, when it was running, was actually being clamped in one place. So it was grabbing, and you probably can't see this on camera very well, but there's some edge damage to the belt where it was being clamped. So I took them off and put these aluminium pieces on. However, I'm not at all convinced that that's particularly well balanced, so I bought another one. This is the type of flange that they came with. I'm doing this intro slightly out of sequence. I've already cut the keyway in it. I haven't got the right diameter, the right across flats piece of high-speed steel to cut the right size of keyway, but that's kind of irrelevant really. So the other issue is the original belt is 20mm in width, which is a non-standard sort of size. So I've bought replacement belt, which is slightly larger than the original, but this is 25mm. So the other thing that I've found, and I don't know, maybe somebody could tell me, the other thing is this pulley that was the original is the same size as the spindle. So in the dimmer distant, I'm sure I remember in lectures saying that gearboxes are designed so they don't factorise. Well, I don't really. So basically the same tooth will hit the same tooth in a belt will hit the same tooth in the pulley every revolution, because it's doing a 1-to-1 ratio. I don't know whether that's a problem with these sort of belts. I haven't done any research into it. So what I've done is, that's a 40 tooth. This one is a 44, I think, something like 42. I'll put it up on the screen exactly what it is. 40, I don't know. Anyway, it's a slightly different number of teeth than you can probably see. It's got a different diameter than the original, so it's slightly bigger. So I'll have more teeth. It will have the effect of speeding the spindle up slightly, which is no bad thing, because I can only get 5,500 revs out of it at the moment. So I think this adds another 400 or 500 revs. Also, because this is now going to be a different diameter to the main spindle pulley, with a different number of teeth, it won't factorise. So these teeth will slowly work their way through, and it'll be, I don't know, 60, 70 revolutions before the same tooth hits the same tooth there. So it should wear evenly. Anyway, that's a theory. I'll also, it appears I'm not very good at ordering online. I managed to get 2. And there are replacement bearings for the squirrel cage, the motor here. While I got it in bits, it just strikes me that it's easier and better to just replace both of them, and we'll see how we get on. So now it's a case of changing the pulleys over, reassembling it in here, and there's the back plate with a wavy washer. Oh, my little furry friend has turned up. Yeah, that means she wants food. Nothing quite like a bit of cupboard love, eh? I cannot get the hub pullers, 3-legged pullers, under the bearing. The bearing is knackered, so I think the only way to get it off is to destroy it. Take the shield off. Should be quite easy. There we go. Destroy the cage. There we go. Right, that's all the bits of the cage out. Push all the balls to one end. And there you have it. Damn it. I think I heard it go crack. Let's see. Oh. Spot on. Okay, I've got that running as smoothly as possible. Not an easy thing to measure, so I'm just eyeballing it. And although the flanges are wobbly, that's not what I'm trying to do here. I'm trying to get the actual body of this pulley running smoothly, or running concentrically. And I think that's about it. Okay. Right. Oh yes. Next up, got to cut a keyway. I've never been very good at that. Let's try the armature in it. Oh yes. Oh yes. Fantastic. Oh. Let's have a quick look. There's a little there's a rubber lip seal on either end. I'll just put a little bit of grease in those. Little wavy washer for some spring tension. Right, while we've got the motor off, it's a rare opportunity to have a look inside and see what the castings are like. Not brilliant by any stretch. Typical. But let me show you this is the top of the spindle. I made an aluminium spacer that just sits under the lock nut here, with, that's a problem with these things, with a little magnet, a little neodyne magnet embedded in it, and under here is a little Hall effect switch. So what that does is provide the once round tack to Mark III for the control software. Let me just see if I can get this out. There we go. That's the actual part number. Come on, focus. There we go. Matsushita, which is Panasonic. It was salvaged from another machine, along with a couple of hundred others. Right, and this post and this post are where the power drawbar sits on. So, and I put all the cabling through the cable loom and out through the trunking into the control panel, and coming back I put the coolant line in. So I'm not entirely sure whether that was a very wise thing to do, but there you go, it comes out from the back there. This is only temporary, eventually I will rewire it or replumb it, and it comes out to a magnetic distribution block, manifold, that's the word, there, to two hoses. Ow, ow, this poor old machine needs a bit of a clean. It's in a right 2 and 8. Look at that. This is the switch to open and close the electric power drawbar. I've got problems, I don't know why. I think this was a hangover from a previous model. It's a little access door, but it doesn't give you access to anything, it just rattles. So hence why there's a bit of sticky foam in there. Okay. I think what's quite common in small machines of this size is the weight of the head is counteracted by a gas spring. That's the top of the gas spring. I'm not a huge fan. I have to say I don't know how many car boots I've had with gas springs that go. I run laser cutters at work, and all of the gas springs go in the doors on those. I think maybe it's because they're not well manufactured. It's hard to tell really, but certainly getting them from a good quality manufacturer makes them last a lot longer. So let's put the motor back on, those pins, those connectors. I don't know whether this is going to come over well on camera, but since we replaced the drive pulleys in here, I've gained a few hundred more RPM. So let me turn that on and we'll see. 5,500 RPM. So that's a significant improvement. I think I've gained about 300 or 400 RPM by just changing the number of teeth in the spindle pulley. By gum, it stops quickly. I've been using this mill for several weeks after replacing the spindle pulleys in the top, and I have to say that it's considerably quieter. It runs smoother, and the vibration, it's difficult to show on camera, but the vibration that we used to get has diminished somewhat. So I think it was a worthwhile thing to do to replace the pulleys. In fact, let me turn that off. In fact, so much so that I have actually been considering putting 2 sets of pulleys in there and a dog clutch, so that you can change between a high and a low gear, because it would be useful, I think, to get 10 or 12,000 RPM out of this spindle. If you could do that, then that would up your material removal rates quite dramatically. So that would be worth doing, but by gum, there'd be a lot of work involved in re-engineering the whole top end here. Anyway, my next thing is to continue re-engineering the electric power drawbar and get that so that it works with sufficient force and is reliable. Anyway, thanks for watching. You know what to do. Hit the subscribe button and the bell notification, and we'll see you next time. Take care. Bye bye.